Welcome to Context Window, your weekly look at the bleeding edge of AI coding tools. Let's see what's new. For weeks, users were convinced Anthropic had deliberately lobotomized Claude Code, making it dumber to save on compute costs. But the postmortem revealed something far more unsettling. The underlying AI model itself was completely untouched.
Exactly. The problem wasn't a degraded grain, but a catastrophic failure in the nervous system and sensory organs. It turns out what users perceive as the model is often just a fragile layer of scaffolding and tooling, prone to breakages that have nothing to do with the core AI's intelligence.
It's a fascinating look under the hood. But before diving into the anatomy of that particular breakdown, the podcast will cover some rapid-fire updates from around the AI tooling world. First up, Meta's massive infrastructure play. They've just inked a multi-billion-dollar deal with Amazon for tens of millions of AWS Graviton 5 processor cores. It's a huge bet on custom silicon.
And a very telling one. For years, the story has been all about GPUs, NVIDIA's H100s, Blackwells, for training large models. But Meta is strategically cornering the market on CPU compute.
Why the shift?
Because as the industry moves from passive chatbots to active, autonomous, agentic AI, the bottleneck changes. Orchestrating multi-step tasks, real-time reasoning, code generation, tool execution, these are incredibly CPU-intensive workloads. The Graviton 5, with its 192 ARM Neoverse v3 cores and a 5x larger L3 cache, is purpose-built for that kind of parallel processing.
So the GPU-rich versus GPU-poor narrative is officially outdated. We're entering the era of the CPU renaissance.
Precisely. Meta understands that having the smartest model doesn't matter if you can't give it the specialized CPU infrastructure to autonomously execute thousands of microtasks in the background. It's about enabling real-world agency, not just theoretical intelligence.
Moving on to OpenAI, they've launched a new Trusted Access for Cyber program, partnering with Microsoft to deploy a specialized, un-nerfed version of GPT-5.4 Cyber for enterprise security teams.
This is a significant move. They're granting exclusive access to a model where standard safety restrictions are deliberately relaxed, specifically for legitimate cybersecurity work like binary code analysis. In return, Microsoft is deploying its entire Secure Future initiative to protect OpenAI's infrastructure.
It sounds like a direct countermaneuver to Anthropic's Project Glasswing.
It absolutely is. While Anthropic focused its defensive AI efforts on tech giants, OpenAI is leveraging Microsoft's deep enterprise roots to embed GPT 5.4 Cyber directly into the workflows of financial heavyweights like Bank of America and Goldman Sachs.
So OpenAI is essentially treating cyber defense as a distinct, highly privileged tier of AI deployment.
They are. By trading their most powerful, un-nerfed model for Microsoft's institutional protection, OpenAI is acknowledging that these frontier models are now critical national security infrastructure. They aren't just selling software anymore. They are brokering digital arms treaties. It's a high-stakes play.
And finally, Google is making a major pivot in its cloud AI strategy. They're expanding Google Cloud and Vertex AI to natively embrace, route, and orchestrate competitor models, including those from Anthropic and OpenAI.
This is a massive concession from a company that historically prefers to own the entire stack. They're recognizing that enterprise developers demand a multi-model ecosystem. They want to use Claude for coding, Gemini for long context data processing, and specialized open-weight models for edge tasks.
So, if they can't win the model war outright, they'll win the infrastructure war.
That's the strategic thinking. By shifting from use our model to use our infrastructure to route to the best model, Google is positioning itself as the universal toll booth for the AI era. It's a pragmatic, mature move that prioritizes developer reality over corporate ego.
All right, that brings us back to our main topic, the incident that sparked the lobotomy claims surrounding Claude Code. For weeks, power users on Reddit and GitHub were convinced Anthropic had quietly degraded their flagship AI coding assistant. They reported massive usage spikes, endless looping behaviors, and a stark drop in coding quality.
And they were right about the degradation, but fundamentally wrong about the cause. On April 23rd, Anthropic published a remarkably transparent postmortem confirming the tool was indeed severely broken. But it wasn't a deliberate downgrading of the underlying model weights to save compute. The API itself, Opus 4.6 and Sonnet 4.6, was functioning perfectly. The failure occurred entirely in the scaffolding, the Claude Code application, the Agent SDK, and Claude Cowork.
So the brain was fine, but the body was malfunctioning.
Precisely. It was a perfect storm of 3 compounding infrastructure bugs and poorly judged product optimizations enacted between March 4th and April 16th.
And what were these 3 critical missteps?
First, on March 4th, the default reasoning effort was downgraded from high to medium. Then, on March 26th, a caching logic bug was introduced that effectively wiped the agent's reasoning history. And finally, on April 16th, a system prompt update capped responses at 25 words between tool calls. Each of these alone was problematic, but together they created a cascading failure.
What's remarkable is that it took Anthropic an entire month to notice this. How did such a severe breakdown go undetected for so long internally?
That's where the slicing effect comes in. These changes were rolled out to different slices of traffic on different schedules. So to Anthropic's internal monitoring tools, the degradation looked like random noise. A user might experience only the March 4th bug, not the one from March 26th, making the issue nearly impossible to consistently reproduce or diagnose until the user complaints reached a critical mass. It was a slow-motion catastrophe.
Let's unpack that first domino, the March 4th change. Anthropic made a product decision to lower Claude Code's default reasoning effort from high to medium. What was the thinking there?
The motivation was user-driven but misguided. Users on slower connections or older hardware were complaining about extreme latency. In high reasoning mode, Claude would take its time, generating a hidden chain of thought before executing a task. To the end user, the UI would appear completely frozen, a perception of unresponsiveness.
And Anthropic's internal testing showed medium mode delivered only slightly worse results on most benchmark tasks, while significantly reducing that perceived latency.
Right. It's a classic Silicon Valley anti-pattern, optimizing for a superficial metric like UI responsiveness at the expense of the core product value, which, for a coding assistant, is intelligence and correct code. While medium reasoning might pass a static internal benchmark, in the chaotic environment of real-world agentic workflows, where the AI must navigate undocumented code bases and complex dependencies, the drop in reasoning depth was catastrophic.
So it's basically the we know better trap, where an organization makes a decision based on internal data that doesn't fully capture real-world user needs.
Exactly. And the users immediately protested. They made it abundantly clear they would much rather wait 30 seconds for correct functional code than receive broken instant code. Anthropic quickly realized their mistake and reverted the change on April 7th, acknowledging that users prefer higher intelligence by default and only want lower effort for simple, repetitive tasks.
That brings us to the second, more insidious bug, the March 26th caching logic error. This one seems to cut to the core of how agentic AIs function. Can you explain prompt caching and why it's so critical?
To understand this, one can imagine an AI agent like Claude Code isn't just reading a prompt and spitting out code. It engages in a multi-step loop. It might read a file, think about it, run a terminal command, read the error output, think about that error, and then write a fix. To maintain continuity throughout this process, the entire history of this thinking and tool usage is appended to the context window and cached. This cache is essentially the agent's short-term memory. It's what allows the model to remember why it made a specific edit 5 steps ago, or what strategy it's pursuing for a complex task.
So it's like a running log of its internal monologue and actions.
Precisely. Now, the bug. Anthropic attempted to push an optimization that was meant to clear this memory cache only after an hour of user inactivity, which would save on compute costs, a reasonable goal. However, the code contained a fatal logic error. Instead of clearing after an hour, the bug caused Claude to discard its own reasoning history on every single turn for the remainder of the session.
On every turn? That sounds devastating.
It was. This induced a digital form of anterograde amnesia, much like the protagonist in the movie Memento. Claude would essentially wake up on every single turn with no memory of its previous thoughts. It knew what its ultimate goal was, say, build a login page, and it could see the current state of the code base, but it had no idea why it had just executed the previous terminal command or what its last thought process was.
The consequences must have been maddening for users.
They were. This led to maddening, repetitive behavior. Claude would write a piece of code, encounter an error, forget why it wrote the code, write the exact same code again, and get stuck in an endless, expensive loop.
And this explains the massive usage spikes that users reported.
Absolutely. Because the cache was constantly being wiped, every single step in the agent's loop registered as a cache miss. Normally, caching saves users up to 90% of their compute limits. Without it, the model was forced to reread the entire code base from scratch on every single turn, effectively burning through resources at an alarming rate. Pro and Max tier users, who expected 5 hours of usage, were finding their limits depleted in just 60 to 120 minutes. It was a total drain.
Just when things couldn't get worse, there was a third issue on April 16th, a system prompt update. This seems to highlight the incredibly sensitive nature of prompt engineering in these complex systems.
It does. The final nail in the coffin was an instruction added to the global system prompt: keep text between tool calls to less than 25 words.
25 words? That's incredibly specific. What was the thinking there?
Anthropic was actually preparing for the release of their new Opus 4.7 model. During testing, they noticed Opus 4.7 was overly verbose when using tools, wasting tokens by explaining what it was about to do before doing it. The instruction was an attempt to curb this verbosity and save tokens.
But it was applied globally, affecting the existing 4.6 models.
Exactly. And by forcing the model to limit its text to 25 words between executing tools, Anthropic inadvertently destroyed the model's ability to engage in what's called chain of thought reasoning. An AI model thinks by outputting tokens. If you cap its output to 25 words, you are literally cutting its thinking time short, severing its ability to elaborate on its reasoning process before acting.
So a seemingly innocuous instruction meant for a new model had a disproportionately negative impact on the current one.
Precisely. Anthropic's later testing with a broader evaluation suite revealed this single sentence caused a significant drop in overall coding quality. Users, however, felt the impact much more severely, especially in complex tasks where deeper reasoning is critical. This change was reverted just 4 days later, on April 20th.
This whole incident seems to underscore a fundamental point about modern AI. What is often called the model is rarely just the raw weights.
That's the crucial takeaway. This entire saga illustrates that the raw power of the underlying AI model, its weights, its training, is only one part of the equation. What users actually experience is a complex system built around that core, a fragile layer of scaffolding, tooling, and orchestration.
So it's like having a super powerful engine, but if the transmission is faulty, the steering wheel is broken, or the GPS is giving bad directions, the car isn't going anywhere fast or reliably.
A very apt analogy. The lobotomy wasn't a defect in the engine, but in the vehicle's control systems and memory. This incident profoundly highlights the fragility of agentic memory and the immense impact of seemingly minor infrastructure or product decisions. It reveals that AI reliability is not just about the model's intrinsic accuracy, but the robustness of its entire surrounding infrastructure.
And it also speaks to the intense industry pressure. The push for faster, cheaper, more efficient AI often comes at the cost of robustness, and sometimes, as we saw with the latency trade-off, core intelligence.
It's a constant tension. This incident serves as a stark reminder that understanding AI means understanding the entire system, not just the capabilities of the core model. The performance of these systems is critically dependent on how they are architected, how memory is managed, and even how prompts are structured.
Wrap up and key insights.
So, looking back at the Claude Code incident, what are the core insights for listeners to take away from this?
First, the model in AI is far more than just its raw weights. The scaffolding, the tooling, the prompt engineering, all are absolutely crucial to its real-world performance and can break independently of the core AI.
Second, agentic memory is incredibly fragile and fundamental. It's not just an optimization, it's the basis for multi-step reasoning.
And third, there's a critical trade-off between perceived latency and actual intelligence. Companies optimizing for speed need to understand the potential hidden costs in terms of output quality.
Fourth, even small, seemingly innocuous infrastructure or prompt changes can have disproportionate, cascading, and catastrophic effects on a complex AI system.
And finally, user feedback remains an indispensable, real-time diagnostic tool for real-world validation, often catching issues that internal benchmarks or sliced rollouts miss.
This whole saga raises some fascinating questions. How can developers and companies build more resilient agentic systems that don't fall apart from subtle caching bugs or seemingly minor prompt tweaks?
And beyond that, what does this incident tell us about the hidden costs and complexities of operating frontier AI at scale, especially as these systems become more autonomous and integrated into critical workflows?
That's all for this episode of Context Window. Join us next time for more on the AI tools shaping how we build software. If you're building with AI, subscribe. We cover what matters.
Ship smarter, not harder.